Okay, the Zoom is recorded now. All right. Good morning, everyone. Welcome to Fit 2107 Software Quality and Testing again. This is lecture 5 already, so time flies very fast. And today we're going to cover three main topics here. Okay, so the first one is called category partition testing. The second one is combinatorial testing, and the last one is pairwise testing. Okay, so the topic today, I think it will be it will be the last three techniques of the black box testing. How can we design the test cases without looking at the code at all? We just read the specification and then generate the test case. Okay. Okay, let's get started. Before I get started, maybe I'll just want to thank everyone who participate in the survey last week. I think it was very overwhelming. We received over 100 response. And this is the result so far. I just want to present to everyone. So basically, in this unit, right, the motivation is that we found that teaching software testing is quite difficult. It's very hard to keep the student motivated and engaged. So how can we address this kind of challenge? And this year is the first year that we introduced the unit testing challenges using the ED STEM. And we also developed the automate marking mechanism as well to see whether we can provide the prompt feedback to the student or not, right? And this is the results that we found so far. We found that 94% of the students, they found that these unit testing challenges keep them more engaged and more motivated as well, and it foster the deeper understanding of the unit testing concept as well. And most of the students, 86%, most of the students found that they enhance overall learning experience so far as well, and also help the learning progress as well. However, while there are lots of pros, right, but there are some limitations or challenges that the student encounter as well. For example, the feedback mechanism is still not that effective. So what we found is that 60% of the students found that automate marking is still better than the human grading. It is consistent, it is prompt, it is promptly, but the feedback is still needs some improvement as well to support the student learning. And this is just some of the quote from the student. There's nothing personal at all, but this one we use this result in the research publication as well. So for example, it may be helpful to give more in-depth instruction in that case, like some of the students suggest to add hints to the test case as well. And sometimes students found that when the test case are failed, it's a little bit hard to manage the cognitive workload as well. So that's why I think there are a few things that we can respond to the student feedback, right? So what we discuss, we take the student feedback seriously and discuss among the teaching staff and try to come up with the solution to help everyone. So this is what we designed. For the studio practices, we will add the check button to test your current work against the teaching team test cases before you can submitting them as well. And then we also add some hint to the test case as well. This is what we plan to do. And for the assignment, it will be something similar, yeah, but the hint will be a little bit more general. So because for the assignment, it is accessible. There will be some marking involved, so it has to be hidden anyway. And yeah, thanks a lot, everyone. And I would just want to show you, this is the paper that we completed based on your response. Okay, so basically we're gonna submit very soon. This is the introduction. This is so we provide some background and related work about software testing education as well. And yep, so this is what we propose so far. Okay, and just want to check if I share the right screen. Is that right? Yeah. Okay. Yeah, so this is the unit testing challenges in ED STEM. What students normally do is that they click the mark button and then they found what test cases are failed, and how can we improve them, how can we write the code to pass the test case, that kind of thing. And this is the marking mechanism that we propose, and this is the details of how do we decide the subject, okay, using lots of learning theories behind, and how do we decide the unit testing challenges as well. And this is the results that we get so far, how we decide the survey questions, survey questionnaire. We received 113 responses. We exclude some of them that do not consent, so we only have 92 response for the rest of the analysis, which is equivalent to 29% of the response rate. And that's the result that we get so far. Yeah, that's it. Okay. Thank you so much, everyone. And we will let you know how the results go. Okay. But but the most important thing is that when we because we work so hard and try to help the student learning software testing as much as possible, right? We just want to remind everyone that feedback is quite sensitive as well. When you provide, some of them, they are quite excellent, they are very constructive. I just really want to thank and really appreciate that. But please make sure that we should try to avoid any inappropriate behavior, inappropriate feedback as well. Some of them are very strong, some of them are not quite appropriate, and I actually forward to the discuss with some of the teaching staff, teaching admin at the faculty level as well, and they agree that probably I should emphasize this in the classroom as well. So in short here, right, just want to say that please try to write the feedback in the sense that humans are reading them, so treat them equally, treat them respectfully as well. Some of the teaching staff need to handle this kind of thing, right? So we should try to avoid any inappropriate feedback. Okay, does that make sense to everyone? Okay, yep, thank you. So I will continue. So this is the today learning outcome, right? And we will talk about the black box software testing, category partitioning, combinatorial testing, and pairwise testing as well. Okay, so these we will cover the last three techniques. Okay, let's start with the category partition testing. Category partition testing, basically it is a technique that is proposed in 1988, right? And the key idea here is very simple. The key goal just in the bold line. We want to test the combinations of the inputs, okay, by categorizing them into different equivalent classes and then selecting representative values from these categories. So looks like it is quite similar to what we did in the past, right? Equivalence partition testing. So what is the difference? The difference is that when we talk about the equivalence partition testing, we only focus on one input domain. For example, is leap year, okay? That's one input, right? Let me try to get the pen. Yeah, we talk about one input variable. Is gym eligible? We talk about one input variable. Okay, and what we did in the equivalence partitioning testing is that we draw the arrow like this and then try to partition the input value into equivalent classes and write the number 1, 2, 3, 4, whatever, right? But for the category partition testing, we are talking about the combinations of input. Okay, combination means two or more. Okay, for example, is valid login, right? There are two inputs here, which is the username and the password. When we talk about the is loan approved, we talk about the credit score and the salary income. These are the two more inputs, and it becomes more difficult because when we talk about, let's say, credit score, right? Probably let's say we have low, medium, and high. Sure, we can have three partition here: low, medium, and high. And salary income also low, medium, and high, right? But the key question is that how can we test them effectively? So what they suggest is that test the combinations of the input. That means for the credit score, we will have three choices, three classes. The salary income, we will have three classes. So we just test all of the combinations. So basically we'll get nine combinations that we need to test. That's a valid test frame, right? And then we also need to add the one invalid test frame as well. So this is the trick that we will use it together, okay? Okay, so there are 5 general steps, so easy. I try to simplify it as much as possible. First, identify what are the tests, what are the input variables, okay? That's the method name. Think about how can I say, when we read the specification, we need to think about what is the method name and what is the input variables to that method, right? So we will talk about this one, the input variables, and probably we should have 2 or more, so we can use the category partition testing, okay? And then the next step is that we understand the characteristics of each variable here, okay? Whether it is in a category or not, the input can be integer, right? Numbers, but we can split into category. For example, in the previous slide, what is that? Credit score. Credit score can range between, I guess, 0 to 1,200, but we can split into low, medium, and high. Okay, that's 3 categories. So once we understand the characteristics of each variable, and then we need to identify the constraint. The goal of identifying the constraint is to reduce the invalid combination. Okay, so we need to remove that. Why should we test that, right? In this case, it's okay. We don't know whether we need to remove anything or not. We will check in the next few slides as well. And then the key point, the keyword here is that it's called generate the test frame. So once we understand the input variables, understand the categories, and then do all of the combination here to generate the test frame, okay? 3 by 3 equal 9, okay? Equal 9, something like that. And then for each of the 9 test frame here, right? Then we just generate one test case, okay? To as a representative of each test frame. Okay. Category, that's category partition testing. Okay, let's take a look at this example. I'll try to add more example as much as possible as well. So this is a user registration form, okay? And normally for the user registration form, there are 2 key input variables, right? The username and the password. And based on the requirement here, they split the username into 3 equivalent classes. So it is short, 1 to 5 character, medium, which is 6 to 10 characters, and long, anything that is more than 11 characters, okay? And password, we have weak, medium, and the strong. So let's try to work on this one together, right? Let's do it together. First, we need to identify the independently testable input variables. In this case, we will have username and the password, easy. And then we're gonna understand the characteristic, right? So based on the specification, this one is quite straightforward. So we have 3 choices for the username and 3 choices for the password here, all right? We identify the constraint among the choices. So we should have, there will be either invalid username, or invalid password. Everything is considered invalid. The only way we can register the user here, right? They should accept, what is that? Yeah, long and strong. This is like what we prefer, okay? So anything below that should be like invalid, okay? So then we generate the test frame, right? 3 by 3 equal 9. So we will get 9 valid test frame based on this combination. And we should also include 1 invalid test frame as well to ensure that we test the invalid input, right? At least 1, okay? And then, okay, let's go to the next slide. So because we have 9 test frame here, because we have 9 test frame, right? 9 test frame plus 1, so we should have 10. Let's count a little bit, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in this example, we already have 10. we generate all of the test frame here. And then we just randomly select one test input that is representative to the test frame. Okay. And then we already know what is the expected output, right? Okay. So only the long username and the strong password, the expected outcome will be the allow. Otherwise, it will be not allow or the invalid input. Okay, that's the how. This is an example. How do we decide the the test cases using the category partition testing? This is quite easy and straightforward. Let's take a look at a more difficult one, right? Would you also not check invalid weak, invalid medium? Yes, we do. This is the invalid weak password, right? Empty, yes, the last one. Yeah. So if the username is empty and the password is empty, then the expected output becomes invalid. Yeah. Okay, we got a question. Can you clarify again? What does it mean? Empty, weak, empty, and medium. Ah, okay. So because I think I understand now. That's the other combination, right? So what the student mean is that right now we only test empty and empty here. Why don't we do the cross combination? Let's say empty weak or long empty like this, right? Because if we understand the constraint here, so when anything that is invalid, it becomes invalid anyway, right? So it is also possible to test, but at the end of the day, the output will be the same as this one. So that's why we don't test it. It is redundant. That's what I mean. Does that make sense? Okay, thank you. Yep. All right. So next one, Christmas discount. Christmas discount. Let's get some pen. Okay. Yep. So what is the specification here? We offer a discount during Christmas. If it is a Christmas date, we will give 15% discount if the total amount of the order is over $500. And if it is not Christmas, then there's no discount. Okay. And actually, I should fix the specification a little bit as well. Is at least $500. Okay, to make it more sense. Okay, so that means when we look at this specification, right, and what is the input variable? Of course, it should be date, right, and the amount. Okay, and then when we read the specification, we can come up with two choices here, whether the date is Christmas or not Christmas. That's it. We don't need to partition into like 365 days. It's too much, right? In this case, we just have only Christmas or not Christmas. Or if the spec has more, if the spec here is more complicated. Let's say we offer discount 50% discount for the Christmas day, or 10% for the Mother Day, or 5% for the Father Day. Then the choice here will be Christmas, Mother Day, Father Day, and nothing. None of these, that kind of thing. So we'll get four choices. Do you know what I mean? Yeah. So we just partition into the smallest number. We don't need to partition to like a large one, right? A large number, too many choices. And then the amount of order should be at least $500. So we will get 500 or not 500. That's it. Okay. Then we'll generate all of the combinations here. There's no constraint for this case, okay? But let's say if I want to add a constraint, we can say that we give 50% discount if the purchase order is at least 500 for a premium members only, but for the regular membership we will give only 5%, something like that. So that's a more no that's the more choices anyway. That's the premium the membership type. Constraint, let me think, let me come up with another example. Constraint. There's no constraint for this one. Okay, we skip. So, okay, for this case, okay, I should not say that. Yeah. So for this case, we will get 2 by 2. So we get 4 valid test frame, and we should test at least 1 invalid test frame. You can test like 100 anyway, right? But the most effective test cases is to test each test frame. Like how can I say? We should come up with uh, one test case for each scenario. And this case, we have only one invalid test case, which is one test scenario, right? So only one is enough as well. At least we test something, okay? Okay, in total, we'll get 5 test frame. And we have Christmas. This is all of the combination here, right? Christmas 500, Christmas not 500 or whatever. And then you can generate the test input here, okay? And then this is the expected output, okay? Make sense, everyone? So in this case, okay, one question in the Zoom chat. So in this case, we are never testing for what happens if say date is invalid, but there is a valid amount. In this case, yes, let's say it depends on the specification, right? In this case, if we apply the category partition testing and we only look into these choices, so we only test whether it is Christmas or not Christmas and the amount. But if the spec is more, say something more, right? For example, the date should be in a valid format in this string formats. Otherwise, it should be like that, blah, blah, blah. So what I want to say here is that when we design the test case, we can use a combination of techniques, but this is only one technique to generate the combination of the test frame, okay? Combination of the test input, okay? So it doesn't mean that when we have one spec and we can use only one technique, we can use multiple techniques to strengthen the test case as well. Yep. Thank you. Okay. Okay, next one, chocolate bar. Okay. The spec here, okay, we want to make a chocolate, okay, we want to make a package of total kilos of chocolate. We have small bars, okay, which is 1 kilo each, and the big bars, which is 5 kilo each. We always use big bar before the small bar. Oh, okay. What does it mean? And the output will be the numbers of the small bar to use or -1 if it cannot be done, right? Okay, so the input will be how many small bars do we have, how many big bars do we have, and what is the total kilos that we can make, that we want to make. Okay, that's the goal. Let's try to understand the first example together. Let's say we have 7 small bar, 7 kilos, 3 big bars. How many do we have? 15. Okay. And what do we want to make? Only 20. Okay. Only 20. Don't make more than that. And the goal, the key point here, the constraint is that we have to use big bar before the small bar, right? So we need to use big bar first. Okay. Then 20 minus 15. How many small bar left that we need to use? So we need only 5. Okay. So the output, that's why it's called 5. No, sorry. That's why the output here is 5. That's the numbers of the small bars that we need to use. Okay. Let's say, let's take another example, right? Let's say 3, 3, 20. Okay. So we have small bar 3, big bar 3, and we need to make 20 kilograms. Okay. Can you help me? What is the output for this one? Maybe type in the Zoom chat. Yeah. -1, thank you, because we cannot make anything, right? We are short of 2 kilos. Thank you. You're right. Okay, that's the the algorithm so far. Okay, that's how we do it. But the key question is that we already know the spec, we understand the input variables. How can we generate the test frame? Okay, let's take a look at this one. We have small bar, that's the input, right? Small bar, big bars, and the total kilos. Next one, we as I mentioned before, we should consider both valid and the invalid test frame. Okay, so for the valid test frame, what are the possible test scenarios here? We use only the small bar. Okay, we only use the big bars, and we can use both of them, small bar and the big bars, and it works perfectly. Okay, what are the possible test scenarios for the invalid test frame? Okay, invalid test frame, we don't have enough chocolate bars to make anything, or we what is that, not from the spec, invalid number, so the number is invalid, we cannot make anything. These are the possible invalid test frame, right? Once we understand this, then we can generate the test frame, no, sorry, generate the test case. Okay, let's take a look at the only big bars here. Everyone is following me, right? Only the big bars. Okay, let's try to expand this one. We have we want to make 10 kilograms. Oh, we have a bunch. Okay, we have enough. Yeah, and we can we have a lot of small bars as well. But in this case, let's say if we combine with what is that, multiple sorry when we test the only big bars, right, there are a range of numbers that we can test, and it is infinite. So the key question is that which test cases that we should use, right? So that's why we're gonna apply the boundary value analysis here, right? So go back to this one. When we talk about the only big bars, okay, what is the boundary value? Let's stick to what is that? Let's say this is what I mentioned before. When we test only the big bars, it can be any number, and it's a lot. But what we should do is that we should test at the boundary number, right? Because when we test like this, there are some cases that we are missing as well. And what is this? For example, we want to test 10, we want to make like a 10 kilograms of chocolate, but we don't have enough big number, right? Sorry, big chocolate numbers. We only have small. That's why we cannot make anything. So that's why we should use the boundary value analysis to test the boundary. And then we need to understand what is the boundary, okay? And in this example, is that because we want to test only big bars, then the boundary here is that we have enough big bars or not enough big bars, right? And this is not enough big bars, okay? So we cannot make anything, okay? And because we want to test only big bars only, so that's why the small bar should be either 5 or 0. We should not use any of the small bars at all, okay? So that's why we need to make this one becomes 5, okay? Okay, so we don't use it. And because actually this one should be 0, I would say. Yeah, only big bars. And big 0, let me fix it now, okay, to avoid any confusion. Let's work on it together, right? Okay, because we're gonna use big bars only, and this one we cannot use anything. That's why it returned -1, right? And then for this one, we can use one big bar to make 5 kilograms. That's why the output here is should be 0, because we don't use any small bars. We use the big bars only, okay? And this one, yeah, 10, okay? 2 big bars, and I think total this is the small bars, right? So we don't use anything. That's why no, that's the total. Sorry, total is 10, but the output we don't use anything. That's a 0, and this one should be 15. Yep, 15. We want to make 15 kilograms using 3 big bars, and we don't use any small bars. So we don't need to So the output will be 0. Okay, this is how we use the boundary value analysis to design the test cases, and we can apply this kind of technique for the other scenarios as well. Only small bar, small and the big bars, that kind of thing. Let's try to work on another example. Okay, small bar, right? Small bar. Let's try to work on the small bar together as well. Only small bars. Okay, small bars, that means we should not use big bars at all. So we're gonna set it to 0. Okay, 0. And the what is the spec? The spec is that we should use the big bar first, okay, before the small bar. But let's say here, right? If we don't have anything, okay, so only small bar, and the other class will be we cannot use any small bar, right? So we don't have enough small bars, so probably it can be -1 as well. -1, okay, but that's not the valid number. Okay. So for this one, what is the output? Let me think. Let's think about it together. I think it should be like this, right? That's what I think. Yeah, 0, 1, and 2. Okay, because the boundary here is a 0 for the small bars only. Okay, let me get the draw. Okay, think about drawing this one. The boundary value only is the small bar. Okay, so small only, yeah, and we have 0, the boundary. We look at the left and on the right. Okay, -1, 1, 2. This is what we want to test. Okay, yep, makes sense. Okay, we got the small bar, big bar should be 0, and the total here should be 1. We want to make 1 and we want to make 2, and the output is 1 and the output is 2. Okay, this is the test cases for the small bars only. Does that make sense, everyone? Maybe yes in the Zoom chat. Okay, clear. Very good. Thank you. Okay, that's the small bars. Okay, I will add the slide here. I will update in the ED stem as well. Okay, next one is called combinatorial testing, right? So basically, this concept is very simple. We just generate the test cases based on the combination or a Cartesian product, right? When we use this one, for example, we use in like a software configuration testing. Let's say we develop an application and we want to test on different browsers and the operating system, right? Let's get a pen. For example, we want to test a web application with 3 browsers and 3 operating systems. So what we should test? 9. Easy. Let's say we want to test a mobile app in various screen resolution. We have 480 these choices of the screen resolution, and we have these devices, 3 devices. So we get 9. 3 by 3, we get 9 choices. Same one, right? Okay, next one. Let's say if you want to test a network protocol implementation by combining different messages type, okay, we have request, response, and error, and network condition. Okay, we have 3 choices here. How many test frames? 3 by 3 equal 9. Same. Okay. This one is also 9. This one is also 9. Ah, that's too easy. All right. Okay, move on. ATM operation here. Another example as well. Let's say we want to design the test case to test the ATM operation. We have 3 different account types. We have 2 transaction types, and we also have 2 types of the balance as well. When we deposit or withdraw, we should check whether we have enough balance or not. Okay, so that's why in total, we have 3 times 2 times 2. We have 12 total combination, okay, for this case to test. But in real world scenarios, right? There are too many choices, too many combinations, and it could lead to combinatorial explosion as well. Let's say if you look at the YouTube, okay, YouTube search bar. Let me try to find an example here. And you have a chance to practice in the studio as well. 1 second. YouTube. How to do? Let me think. What should we test here? Music. Okay. So I'm gonna move this one to the screen share. Do you see the browser, the YouTube one? Maybe say yes in the Zoom chat. If not, then I need to reshare the screen. Do you see the YouTube screen sharing? Yes. Okay. All right. Yeah. So in this case, right, let's say you are a Google software engineer. Thank you. Thank you. Yeah, let's say you are Google software engineers, and this is the YouTube search filter. Okay. There are so many combinations. Let's say in this case, if you want to test how many combinations that we want to do, right? Upload date, how many options? Last out, today, this week, this month, this year, 5. Okay. We have 5. Okay, let's try to work on this one together. 5 times 4 times 3 times how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 and another 3, right? Okay, let me get the calculator. How many choices that we need to do? 4 times 3 times 11 times 3. We have in total, what we need to test is 10560, right? So that's a lot. This is like the total combinations that we need to test just for the YouTube search filter. And can we do that or not? Probably no, right? Let's say if it takes like a 1 second for each test, okay? I'm gonna translate into how many hours, okay? Let me try. Seconds to hours. It will take 2.9 hours just to test this all of the combination here. So it's too much time consuming. That's why we need another approach, okay, to reduce the numbers of test cases, and it's called one of the solution is called pairwise testing. Okay, what is the pairwise testing? Pairwise testing means it is a technique to test only the pairs of the parameters. Okay, so that means this is by definition, right? Pairwise, it means n-wise. N-wise. So in this case, when we talk about the pairwise, it is only 2-wise. Okay, so given any n parameters, every combinations of values of these n parameters must be covered by at least one test case. Okay, what does it mean? Let's say 2-wise testing here, right? We have this is the first variable. Okay, the first variable. We have what is maybe what should I say? X, A, and B. This is the first variable. We have 2 choice, A and B, and another variable Y. Okay, we have also A and B. Okay, so what do we need to test here? Is like we generate all pairs, right? A B B A B B. Okay, then we test all of the pairs for all of these combination, which is easy. This is the small scale problem, but when it becomes larger, I will tell you how to do. Okay, in the next few slides. Okay, so the key goal of the pairwise testing is that when we have lots of combination, we test like a pair. And for this case, we don't talk about the code coverage, but it should be pair coverage. How many pairs, how many possible pairs that have been tested once, okay? At least one test case should cover that pair, right? That's by definition. And the advantages here is that it can reduce the numbers of test cases. It makes the software testing activities more efficient as well. And the last thing is that pairwise testing only focus on covering all of the possible pairs of parameter values, not line of code, not statement or whatever at all. We talk about the pairs, okay? Pairs of the choices. Okay, let's take a look at this example, right? So this is a technique that we're gonna work together, two-wise or the pairwise testing. Let's say we have the three input parameters here. We have X, Y, and Z, okay? Each of the input variables, we have two choices, A and B, A and B, A and B. Because we have two choices, and two choices. So in total, how many combinations that we're gonna get? 2 times 2 times 2, then we'll get 8, right? So we get 8 test cases here, which is easy. All right. So how to reduce the test case? Okay. The key goal, as I mentioned before, when we say pairs, right? If we look at the first test case here, okay, A, we can generate. There are 3 pairs for this test case. Okay, the first AA, the last AA, and actually it should be this one. A for the X and the A for the Z, okay? That's the pairs, okay? And by definition, there should be only one test case that actually cover each pair, right? Because the TC1, it already cover these 3 pairs. So that's why we're gonna remove the redundant test cases that actually test the same thing, okay? With the TC1, we're gonna remove it. So the key goal is that the trick here, okay, is a little bit tricky. So we're gonna keep this one, right? We're gonna keep, this is how we work. We're gonna keep this one. For TC1, it can, there are 3 pairs, okay? AA, XY, okay? YZ, AA, YZ, and AA, XZ. So we're gonna remove anything below that are duplicated. Look at the TC2 here. This pair is duplicated with the TC1. Is that right? They are the same. So that's why we're going to remove it. Next, we look at the AA, this one, okay? AA. Anything is the same, we're going to remove it. So we're going to remove TC5 as well, okay? Because it tests the same as the same pair as the TC1, okay? And what else we can remove? A for the X and A for the Z here. So we're going to remove the TC number 3 because it is duplicated, okay? Right now, we can keep TC1 and then we remove test case number 2, number 3, and then number 5. Okay, so all good. Then we take a look at the next one. TC4, we're gonna keep it. This is what we're gonna keep and then remove anything that is duplicated for the rest. We look at the first pair, AB. Okay, we already removed TC3 already, so which is fine. AB here, anything? No, nothing. We're gonna remove BB here. Okay, this is a duplicated TC8, so we're gonna remove it. Yep. Okay. Next, we're gonna keep the TC6 here, right? TC6, BAB. How many pairs that we can generate? BA, BB, and then AB. All right. And then we look for the duplication below, okay? Is there anything to remove? BA? No. AB? No. It's not the same as the TC7, so we don't need to remove anything. That's all fine, okay? And then look at the next one. Anything to remove? Nothing, so we're gonna keep it. So in this case, when we use the pairwise testing, we can keep the TC1, 4, 6, 7, and then we're gonna remove 2, 3, 5, 8, okay? Let's take a look at the solution. Okay, they're the same, all right? That's how we test it, right? That's how we work for the pairwise testing. And when we look at the final results here, you can see that these are all the pairs, okay, that we generate, okay, that we test later, and there's no duplication at all, as you can see, right? So the remaining test cases depend on the way we remove it. We can end up with 1, 4, 6, 7 or 2, 5, 2, 3, 5, 8 as well. They are the same, okay? As long as there are no duplication, duplicate pairs in the remaining test cases, they are all correct. And to confirm whether my implementation is correct, my thinking process is correct or not, I actually I found this Python library here. Okay, all pairs pi. Okay, so I'm gonna check this one a little bit. Okay, github.com. Okay, I have this one already. Oh dear. This is a very useful Python library to automatically generate the pairwise combination here, okay? So it provides an example already, right? In this example, we just import the lab. First, we need to import the library, put the choice here. For the X variable, we have AB, Y variable, we have AB, and set AB as well. And then it generates the pairwise all of the combination. And as you can see, finally, we have only 4 test cases. They are the same. And the choice, they are the same as well. AAA, BBA, BA, B, and ABB. They are the same as this one, okay? Okay, so let's try to work on the a more complicated example here. So we have 3 more choice now, okay, for the X variable, ABC, AB, and AB. So how many combinations? Okay, before I move on, just want to check if I understand clearly or not in the previous slide. Yeah, maybe say yes in the Zoom chat before I move on. Yes, okay, good. Now I can move to the next one. We have 3 choices here. 3, 2, 2. How many? Help me. 3, 2, 2. So we get 12, okay? So we have 12 test cases here. We generate all of the combination and then we're gonna work together, okay? As I mentioned before, start with the first one, keep the first one, remove any duplicate pairs below, okay? So we look at AA here, right? What is duplicate? This one, TC2, we're gonna remove it, AA, okay? And AA, this one, we're gonna remove the TC3 as well because it is duplicated with the TC1. Okay, let's work together. And the last one, we're gonna remove TC5 here, okay? Because this is duplicate. Make sense? Okay, we have, for the first test case, we generate 3 pairs. Anything duplicated below, because the goal, we just want to test only once. So we remove it. These are redundant to the TC1, all right? Next, we're gonna keep TC4. TC9 has to be removed as well, right? Yeah. TC9, no, not yet, because we remove only once. I think we will not remove more than that, okay? Yeah. So next we're gonna keep TC4. Okay, we're gonna keep TC4 and then we're gonna remove, we generate 3 pairs. AB for the XY, BB for the YZ, and AB for the XZ, okay? So anything that is duplicate below, we're gonna remove it once. We remove TC8 here, BB, this is BB, okay? BB. And we need to remove AB here as well, it's gone. AB here, TC3 is all gone as well. So, okay, all done. Next, we're gonna look at the TC6. Okay, keep TC6 and then how many pairs do we get? 3. BA, BB, and AB. BA below, no, nothing. BB, we're gonna remove BB, it's all gone. Okay, and we're gonna remove AB, AB here. Okay, remove it. Okay. Next, we're gonna keep the TC6, 7. Number 7 here, we have BB, BA, and BA. Okay. So BB, this one is already removed. Okay. BA, no, nothing to remove. BA, this one probably we can remove. Okay. Yep. And then we're gonna keep the TC9. Okay. CAA. Is there anything that we can remove below? Nothing. Okay. And then what else? CA, nothing. AA, no, nothing to remove below. So we're gonna keep it. Yeah, and then we're gonna keep the TC12 as well. And let's take a look at the solution here, right? They're the same, okay. And when we use the Python library here, it generates the same pairs as this one in the green color as well. So the key question here, right? In the Zoom chat, why TC9 is not removed? Yeah, I think it is because if you remove TC9, it will not cover the CA pair. That's right. That's right. Yeah, that's right. So that's the right thing, right? That's the answer. So because if we remove this one, we will not have the CA pairs to cover. So we will not remove it. Okay. All right. Does that make sense? Try to use the if this is like how you do it manually, right? And you can confirm the results by using the Python library, this one as well, to check. And because we still have time before I move to the cheat sheet, I just want to do some demo a little bit as well. This week, for week 5, right? Task 2. This is an example for task 2. No, this is an example of using pairwise testing. And because, what is that? There are so many choices here, right? Let's say if you want to use the pairwise testing, how to do it, right? So you can check the task 3 as well to reduce what is the test frame that we should test for the pairwise testing in these scenarios. So if you go to the task 3, because the the ED stem does not allow, is not connected to the internet, right? So I already set up the Python package library, this one in everyone student repository in the workspace. So what you need to do is that, let's try to read, what you need to do, okay, follow the instruction like this one, right? So this is what you are, this is your workspace at the moment in the Python, in the EDSTEM workspace. What you need to do, you need to unzip, okay? Unzip the Python package here, okay? And then you cd change directory, directory this one, and then you need to install, but you need to install locally. So you need to put the option dash user, okay? Python setup install user. So like this one, it will install, the Python package is installed successfully, and then you go back to the main directory here, right? So what you need to do next is that to follow this example code, learn from this one basic usage a little bit. I think it is quite simple, like really simple. So you implement, modify the choices a little bit, and then try to run it, right? And then it will generate all the pairs. All pairs.py. This is what I already implement for this task, and then enter. So at the end, it will generate 20 choices, okay, for this one. All right. This is what we need to do for the pairwise testing, and most likely we will use the pairwise testing in the assignment as well. So please make sure you learn this Python package, how to generate the minimum numbers of test cases that cover all of the possible pairs, okay? Cover all possible pairs does not mean that it covers all of the lines, okay? It does not imply 100% code coverage. And this Python package is quite handy as well because it is provide an option, the filtering option, right? So you can define like if else here as well, which one is the valid combination, invalid combination, and then you just put the filter function here as well, which is very handy. And because of that, you can generate the pairwise testing where you exclude the invalid combination, okay? So you can reduce that as well. And you can also combine with the test case, unit test as well. In this case, you can use the test parameterize to automatically generate the combinations based on the pairwise testing, okay, to test here. Let's say you want to test the brand, I think mobile devices brand, no, computer, and the operating system and the minute, right? And this is the function that you want to test, okay? This is what you do. Yeah, try to study this one a little bit as well. It will be very helpful. And okay, go back to the last slide and cheat sheet. Okay, so in short here, boundary value analysis should be used for the single input value. Okay, let's say, and it should be the numbers as well. Decimal values is also fine as well. Is sick temperature. This is one of the example. Equivalence partition testing, continuous input value divide into classes. This is what we do. But when we have two or more inputs, we're gonna use the category partition testing. You can partition you can identify the category first and generate all of the combinations and then apply the boundary value analysis to identify the boundary value and generate the test cases as well. You can use the decision table if the and we also have combinatorial testing as well. But if the combination is too large, we need to use the pairwise testing. Okay, and the last question from the Zoom chat for task 3 of the assignment 1, what kind of testing do we employ? Okay, because I understand that it's kind of overlap, right? But for the task 3, I would say that we only focus on the unit testing. We do not, you can consider using black box testing, that kind of thing for your task 3, but I would say it is still optional because whatever exists in the week 4 and week 5 will be assessed in the assignment 2 in the next assignment. So we do not technically expect you to apply this kind of testing technique in the task 3 of the assignment 1. But as I mentioned before, you need to read the marking guide carefully. We assess the task 3 based on the private test cases that we provide. No, that we already developed, right? So everything we expect that the code should be functionally correct, and you should test every line of code as well. This is what we expect so far. Okay, does that make sense? So it's more so exploratory testing in task 3. Sure, you can do that. I'm not too concerned. As long as you pass the hidden test cases and you test every line of code, you will get the full mark. Does that make sense? So there's no mark in the ED STEM. Do you mean for the assignment? Yes, that will be it is accessible. Can we access another question? Can we access the test cases now? We are working on it, and we are likely to release by tomorrow morning. Okay, yeah. Yep. So the mark button will be released by tomorrow morning at the latest. Any other questions? Okay, I think that's all. And then we will talk about the white box testing in next week as well, week 6 and the 7th. Okay, all right. Thank you, everyone. I will stop sharing the screen and see you in the afternoon. Yeah, bye-bye.